This is section 6.4, page 2. So here the first theorem we have is saying that when we subtract two fractions, that's the same as adding the opposite. Okay, so we just change this into a plus sign and make the second fraction negative. And so, an example of this with whole numbers would be something like this. If we have 9 minus 5, that's the same as 9 plus negative 5. Okay, so with fractions, it's the same idea. All right, so I guess maybe I should talk about the answers for here, the answers for here. When the signs are different, we subtract the numbers and take the sign of the larger. So either way, we get the same answer. Okay, so in this example, it says perform the operation, express your answers in simplest form. So here we're going to go ahead and say, well, we are going to use this rule. So we're going to write down the first fraction, and then the subtraction sign, we're going to change it to a plus and take the opposite of the second fraction. Well, the opposite of a negative is a positive. So remember, we have seen this rule before. Let's go ahead and write it in red. The rule says, can you see all that? Let me move it over. A minus a negative b is equal to a plus b. That's our rule, okay? So that's exactly what we did here. We put two negatives in a row turned to a positive. Okay, well now it becomes a pretty easy problem to do. We have 4/5 plus 9/5. We're going to add the numerators. The denominators are the same, so we can go ahead and do that. So we get 13 over 5. It doesn't say that you can't leave improper fractions, so you could leave it like this, or we could go ahead and figure out what it would be as a mixed number. So we're going to go off to the side here and say, well, 5 into 13 goes 2 times with 3 left over. So the other answer would be 2, whole number, and 3 is our remainder, so 3/5. Okay, so either answer here. Okay, excuse me. On to the next problem. Here we have 8 1/4 minus 1 5/6. Okay, well, the issue here is if we're going to try to subtract these two things, we have got to get common denominator. And because we have mixed numbers, it's probably best to go ahead and convert into improper fractions. So let's start with that first. Let's go ahead and make this an improper fraction. So we're going to say 8 times 4 is 32, plus 1 more is 33. So we'll say 33 divided by 4. Then we're going to subtract 1 5/6. So 1 times 6 is 6, plus 5 more is 11. Okay, so that's our problem. But now we see, well, we can't subtract because they have a different denominator. So we want to go ahead and calculate the new denominator. Let me slide this over a little bit more. Okay, so LCD, what is our LCD going to be? Well, remember, we start with the larger fraction denominator, so 6. And we say, does 6 work? Well, no, because 4 doesn't go into 6. So then we say 6 times 2 is 12. Does 12 work? Yes, it does. 4 goes into 12, 6 goes into 12. So that's our LCD, 12. So now we need to convert each fraction into a denominator of 12. Oops, let's leave a little bit more room there. Okay, so we have 12. So 4 times what is 12? 3. So whatever we do to the denominator, we've got to do to the numerator. So we get 99 here over 12. And then we're going to do the same thing with 11/6. Trying to convert it to 12. Okay, so how do we get from 6 to 12? We need a 2. So 11 times 2 is 22 twelfths. Okay, so we're going to bring these back over. 33/4, what was it? 99 twelfths. And 11/6 got converted to 22 twelfths. Okay, now I have a common denominator. I can go ahead and subtract the numerators. So 99 minus 22, leaving the denominator the same, is going to give us 77 over 12. So we can possibly leave that as an answer, or we can convert. and say, well, how many times does 12 go into 77? About 6 gives us 72 with 5 left over. So that's going to give us 6 is the whole and 5 twelfths. Okay, so either one of these answers. I'm not sure which answer the textbook is leaving. They say simplest form. They don't say anything about improper, so we're probably okay either way. Okay, what I want you to do now, I want you to pause the video, go ahead and do your classwork problem, number 6C, read this theorem, and then start the video again. Okay, we're back. So density property of rational numbers, it says that there's between any two fractions, you can find another fraction. So here we have two fractions. Well, right now it doesn't look like there's anything between those. But you know, if you put them on a number line like this and put 0 here and 1 here and divided this into 5 equal pieces, that's going to be hard. I should have done that. Okay, so that needs to be moved over just a little to make it look more equal. Okay, so this would be 1/5, 2/5, 3/5, 4/5, 5/5, or 1. Okay, now can you see that there has to be something in between 3/5 and 4/5? There's something here. Okay, because here's our 3/5 and here's our 4/5. There's space between, so there's a fraction between there. So how would we go about finding it? Well, the key is make the denominator bigger. Make the denominator bigger. Or you want to put more little pieces in between here. So if you divided each one of these into pieces, you know, that's one way to look at it. So in fact, let's do that. Divide each one of these. Okay, so then how many do we have? If we count them up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 now. So what would this number be right here? Well, it's out of tenths because we divided it into 10 equal pieces. How far along are we? 1, 2, 3, 4, 5, 6, 7. So 7/10 is in between these two. Well, if you don't want to draw the picture every time, what we'd do is we'd say, take 3/5, turn it into tenths. And what do? We have to multiply top and bottom by 2. So that gives us 6/10. Take 4/5 and turn it into tenths. Again, multiply top and bottom by 2. We get 8/10. So what's in between? 7/10. Okay. And we could see that with the picture. So that's how you go about doing that. Now, if it didn't work going to tenths, you may have to even go bigger. So first you need a common denominator with the fractions. So if they start off with something like 3/4 and 4/5, you've got to get a common denominator. If that doesn't do it, keep making the fraction bigger and bigger until you can finally find a number in between. Okay, you've got quite a bit of classwork to do here. Do those problems and then you're done with the section.